Humans have always looked up at the stars. We have wondered about our place in the vast cosmos. Are we safe here on our little blue planet? Or is danger lurking just beyond our sight? The idea of the world ending has fascinated us for centuries. We tell stories about it. We make movies about it. These tales range from ancient myths of angry gods to modern visions of technological doom. This fascination isn't just about fear. It is also about curiosity. It is about understanding the universe and the powerful forces that shape it. We want to know what could happen. We want to know if we can survive. This deep-seated curiosity drives scientists to explore even the most unsettling possibilities. We study asteroids that might cross Earth's path. We ponder the immense power of black holes. We even consider scenarios born from our own actions, like nuclear war or runaway artificial intelligence. Among these grand cosmic threats, there is one that sounds like science fiction. Imagine a star, a sun from another solar system, wandering too close to our own. Could such a celestial visitor disrupt the delicate dance of our planets? Could it perhaps even fling our Earth out into the cold, dark emptiness of space? This is not just a wild idea. It is a question that scientists are seriously investigating. The universe is a dynamic place. It is constantly changing. So let us embark on a journey to explore one such cosmic possibility. The day a passing star might come calling, uninvited, to our cosmic neighborhood. What exactly is this wandering star scenario? Imagine our sun and its family of planets peacefully moving through the Milky Way galaxy. Our galaxy is not empty. It is filled with hundreds of billions of other stars. Most of these stars are incredibly far away. Their gravitational pull on us is tiny, almost unnoticeable. However, stars are not fixed in place. They too are orbiting the center of the galaxy. Sometimes their paths can bring them relatively close to each other. Close in cosmic terms can still be a vast distance, but if a star passes near enough to our solar system, its gravity can act like an unwelcome intruder. This passing star doesn't need to collide with the sun or Earth to cause immense problems. Gravity is a force that acts across space. The closer and more massive the star, the stronger its gravitational tug. If a star ventures too close, its gravitational influence can disturb the finely tuned orbits of our planets. Think of it like a bowling ball rolling near a set of carefully arranged marbles. Even without a direct hit, the bowling ball's passage can scatter the marbles. Similarly, a passing star can perturb the paths of planets, pulling them slightly off course. This slight nudge can have dramatic consequences over long periods. The specific theory we are exploring is the ejection of Earth from its orbit. This is a truly catastrophic idea. How do scientists figure out if such a dramatic event could actually happen? They don't just guess. They use rigorous methods. Recently, a significant study shed new light on this very question. Researchers Nathan Cabe from the Planetary Science Institute and Sean Reynolds from the University of Bordeaux conducted this important work. Their findings, submitted to the research repository ArXiv in May 2025, suggest our solar system might be less stable than we previously thought. This is a big statement. For a long time, most models of the solar system's future treated it as an isolated system, unaffected by outside forces. Cabe and Reynolds took a different approach. They recognized that our solar system does not exist in a vacuum. It moves through a galaxy filled with other stars. These stars can, and do, pass by. Their study incorporated the potential gravitational influence of these passing stars. To do this, they ran thousands upon thousands of complex computer simulations. Each simulation was like a virtual solar system, evolving over billions of years. The results of these simulations were quite eye-opening. So what are the actual chances of Earth being cast out of the solar system by a wandering star? According to the study by Cabe and Reynolds, the probability is small, but not zero. Over the next 5 billion years, a timescale comparable to the remaining lifespan of our Sun, they estimate there is approximately a 0.2% chance of Earth being flung out of its orbit. This translates to a 1 in 500 chance. While these odds might seem reassuringly low for any given year, over the vast expanse of cosmic time, even rare events can become possibilities to consider. To put this into perspective, imagine a lottery with 500 tickets. Only one of those tickets leads to Earth's ejection. It is unlikely you would pick that specific ticket on any single try. However, if you kept playing that lottery for an incredibly long time, the possibility of eventually drawing that ticket increases. 5 billion years is an almost unimaginable stretch of time. During this period, many stars will pass by our solar system at various distances. Most will be too far away to have any significant effect. The potential disruption from a passing star doesn't just threaten Earth. The entire solar system could feel the effects. Cabe and Reynolds' research indicates that our planetary system as a whole is significantly less stable than previously believed when these stellar flybys are factored in. This means that other celestial bodies in our cosmic neighborhood also face risks of collision or ejection. The gravitational tug of a passing star can ripple through the solar system, unsettling the orbits of multiple planets and smaller bodies. It's like a delicate mobile. If you disturb one part, the whole structure can wobble. Pluto, the distant dwarf planet, appears to be particularly vulnerable. The study estimates that Pluto has a roughly 5% chance, that's 1 in 20, of being lost from the solar system over the next 5 billion years. This loss could mean it collides with another object, perhaps another dwarf planet or even one of the ice giants. How exactly can a star that doesn't even hit us cause such chaos? It all comes down to gravity. Every object with mass exerts a gravitational pull. Our sun's gravity holds the planets in their orbits. But if another star, a massive object in its own right, passes close enough, its gravity will also tug on everything in our solar system. The closer the star, and the more massive it is, the stronger this unwanted tug will be. The study by Cabe and Reynolds identified that stellar encounters within about 100 times the Earth-Sun distance, or 100 AU, are the most dangerous for planetary stability. The speed of the passing star is also a critical factor. Imagine trying to grab a fast-moving ball versus a slow-moving one. You have more time to interact with the slower ball. Similarly, a star that passes through our solar system's neighborhood slowly will exert its gravitational influence for a longer period. The thought of a rogue star disrupting our solar system is certainly unsettling. But how does this threat compare to other potential apocalyptic scenarios that often capture our imagination? We hear about giant asteroid impacts, for instance. An asteroid impact, like the one that contributed to the dinosaurs' extinction, would be devastating locally or even globally. However, such an impact is unlikely to eject Earth from the solar system entirely. It would cause immense destruction on the surface, but the planet itself would remain in orbit around the sun. The threat from a passing star is of a different, more fundamental kind. Then there are wandering black holes. While the research by Cabe and Reynolds provides fascinating insights, it is important to acknowledge the uncertainties involved in such long-term predictions. Forecasting the precise future of the solar system over 5 billion years is an incredibly complex task. One of the biggest uncertainties lies in predicting the strength of the most powerful stellar passage that will occur during this vast time frame. Will it be a relatively distant flyby with minor effects, or a much closer, slower encounter with more dramatic consequences? The difference between these possibilities is enormous, uncertain by orders of magnitude, according to the researchers. This uncertainty means that the true spectrum of how our solar system might evolve and the range of potential planetary instabilities is broader than what models considering an isolated solar system would suggest. So, should we lose sleep worrying about a rogue star snatching Earth away? The straightforward answer is no. The probability of this happening, while not zero, is very small, about 1 in 500 over the next 5 billion years. Humanity faces far more immediate challenges on much shorter timescales. The Sun itself will eventually expand into a red giant in about 5 billion years, likely engulfing the inner planets, including Earth. This stellar evolution is a more certain, though equally distant, end for our world as we know it. The passing star scenario is just one more thread in the rich tapestry of cosmic possibilities. Instead of fear, perhaps the more appropriate response to such scientific discoveries is a sense of awe and wonder. Learning about these grand cosmic events reminds us of the immense scale and power of the universe. It underscores how special and in some ways fortunate our current situation is. A stable planet in a habitable zone around a relatively calm star. Conditions that have allowed life to flourish for billions of years. Studies like those by Cabe and Reynolds expand our cosmic perspective, showing us that even our solar system is not an island,